In this section, we're going to review something that you've probably already learned, but it's such a fundamental skill, it's going to be really important. So the I can statement for 2.3 is I can solve systems of equations by substitution. So go ahead and write the word substitution. Substitution. Now, as a warm-up for this, and this might seem unrelated, but if somebody asked you for $1 and you gave them 4/4, did you give them what they wanted? Well, technically, yes. Maybe might be a good answer. So I'm going to put maybe. Is 4/4 what they meant? For that, I'm going to put probably not. They probably wanted a dollar bill. Now, 4/4 is equal to $1. It just looks a little bit different, okay? So keep that in mind as we go through and talk about substitution today. So the most basic way to solve a system of equations is by graphing, but it's not very accurate. It takes a lot of time and a lot of effort. So we can save a lot of time and effort and get more accurate answers. Accurate answers using algebra. So that's what we're going to practice using today. Now, there are two algebraic techniques that we use to solve systems of equations. Before we learn them, we're going to remind ourselves of a couple of things. So first of all, there are three things that can happen when we graph two lines. One thing that can happen, and this is what happens most of the time, is they cross like this. We get one single point. So we've got one answer. We know that that's called consistent and independent. There are times where we've got a line that looks like this and then a line that's right on top of it. And in that case, we get infinitely many solutions. So we get one solution here. We call that consistent and independent. We get infinitely many solutions here, and we call that consistent and dependent. And then we can also have something like this. We can have two lines that look like that, and in which case we have no solution, and the word that we use for that is inconsistent. Okay, so those are the three things that can happen. And one more reminder, we always write our answer as an ordered pair. We write the x first and the y second, and we put those in parentheses. Now, the first technique that we're going to learn, the first method, is called substitution. And we need to be really good at substitution, not just to be able to solve systems of equations, but for lots of other things. So here are the steps, and it's going to seem like a lot, but it's really not too bad once you get used to it. So the first thing we're going to do is we're going to isolate one of the variables in one of the equations. Now, notice that's not very specific. It just says isolate one of the variables in one of the equations. It really doesn't matter which variable or which equation, but you want to choose the easiest equation and the easiest variable. Now, a lot of times that step might be done for you. It's going to be pretty obvious if something's set up for substitution, so keep an eye out for that. The next thing we do is we substitute the equation in step one into the other equation. So you've got to make sure that you plug it into the other equation. Don't plug the equation back into itself. That's just like going around in circles. And always use parentheses. Parentheses when you're plugging things in, when you're substituting. So once we've plugged that in using parentheses, we solve the resulting equation to find the first part of the solution. So we're going to get part of the answer, and then we're going to take the answer that we got there, we're going to substitute it into, the answer in step 3, we're going to plug that into one of the equations. Now, it doesn't really matter which equation, but usually it's going to be step 1, that equation that we used from step 1. That's going to be the best one to plug in. Solve the resulting equation to find the second part of the solution. So we find the first part here, we find the second part here, and then of course we always write our answer as a set of ordered pairs, okay, or ordered pair. All right, now this sounds really hard. It sounds difficult. My gosh, I've got to go through these 6 steps all the time. But it's actually much easier, and here's the important part, it's more accurate than graphing. Okay, so we're going to try one right here and take a look at this one. We've got our system of equations. Step 1 is isolate one of the variables. So that means get one of the variables all by itself. So notice that step 1 is done for you. Okay, this will not be the case most of the time. Most of the time you're going to have to do step 1, but step 1 is done for us here. You'll notice that the x on this one is all by itself. So here's what we do. We substitute that into the other equation. So once it's isolated, we substitute that. This is the equation that's isolated, the variable that's isolated. We substitute that into the other equation. And what we mean by that is we're going to take whatever x equals and we're going to plug it in right there. Now let's come back to the warm-up question here. This equation is asking for an x. But instead of putting x, we're going to put what x equals. We're going to put 2y plus 1. So this is like it's asking for $1, and instead we give it something that looks different. We give it 4/4 instead. But watch the advantage that we have here. So I'm going to do this in parentheses. I'm going to rewrite that first equation. So it's going to be 2, where there's an x. We're not going to put an x. We're going to put what y equals, or sorry, what x equals. It equals 2y plus 1. Then we've got the plus 4y, and then equals 26. So I'm going to pause right here to make sure everybody's clear on what's going on. So I've got the 26, that's right there. I've got the equals, that's right there. I've got the plus 4y, that's right there. I've got the 2, and instead of an x, the only thing that changed from right here to right here is instead of an x, we put a 2y plus 1. Now the reason we do all that is because we can't solve an equation that has 2 variables in it. We can solve equations with 1 variable in them. So once we have it here, this looks like an ugly mess, but at least it's only got 1 variable and we can solve this. We're pretty good at these. So we're going to distribute. We're going to simplify before we solve. Whoops, that's going to be a 4. 4y plus 2 plus 4y equals 26. Let's keep simplifying. That's going to be 8y plus 2 equals 26. We're going to subtract the 2, get that to the other side. We're going to have 8y equals... that's going to be a 24, and we're going to finish solving this by dividing by 8, so we end up with y equals 3. Now I'm going to put a dotted circle around that because we know that y equals 3. Now we're actually right here. We're like halfway through. It seems like that's a ton of work to get halfway through, but as far as work goes, we're actually way more than that. Let me show you how easy it is to finish this off. We're going to take this and we're going to substitute it back into either one of these, but this is the simplest one. So I'm going to change colors here, and I'm going to say wherever there's a y, we're going to put a 3. So I'm going to come up here and I'm going to put a 3 right there. So this equation is asking for a y. We're going to give it a 3 instead. It's asking for $1. We're going to give it 4/4. It looks different, but it's the same thing. So this is going to be x equals 2. Put what y equals. Y is equal to 3, and then plus 1. So x is equal to 6 plus 1, so x is equal to 7. So there's the other part. You'll notice that the second part was way easier than the first part. This took a heck of a lot of work to figure out that y was equal to 3, but now we know pretty quickly that x is equal to 7, so here's the answer. We're going to write down 7, comma, 3, put a set of parentheses around it. We're all set to go. All right? Okay, so that's how we solve one using substitution. Now, again, you don't really memorize these steps here. You just kind of get used to going through and doing these. So let's do a couple more, and then you'll be ready for the assignment. So let's take a look at example 2a. On this one, step 1 isn't done for us. You'll notice that none of these variables are by themselves. The x and y are together on this one, and the x and y are together on this one. So we need to choose one of these 4 variable terms, either the 2x, the negative y, the x, or the 3y to get by itself. I think everybody would agree this is probably the easiest one right here to get the x by itself, because this one has a negative on it, the y does. This one has a 2 in front of it, that one has a 3 in front of it. If you've got a coefficient in front there, that's going to end up making fractions when we try and solve for it. So this is going to be the easiest one. So let's go ahead and do this. Let's subtract 3y. Subtract 3y, and we get this. X is equal to negative 3y minus 11. So wherever there's an x, we can put 3y minus 11. So in other words, if somebody asks for $1, we can give them 4/4 instead. So we're going to take this and we're going to plug it in right here. So let me rewrite this. So there's going to be a 2, something that x equals, and then minus y equals 6. So you'll notice that I've just written down a copy of this equation. The only thing that's not there is I didn't put an x there. Because I'm not going to put an x, I'm going to put what x equals. So x is equal to negative 3y minus 11. Let me make that look a little bit better. Negative 3y minus 11. Now let's go ahead and distribute so we can solve this. And it just so happens on this problem and the previous one, we end up doing solving for y first. That doesn't always happen. Just happens to be on this particular one. So let's check and see what we've got here. This is going to be negative 7y minus 22 equals 6. We're going to add 22, so we get negative 7y equals 28. We're going to divide by negative 7, so we get y equals negative 4. Okay, so there's that part of the answer. There's the first part. But remember, we're halfway there as far as the number part of the answer, but the work is mostly done because we're going to take this and wherever there's a y, we now know what y is. Y is -4. So we're going to put it in this one right here. So I'm going to write down x is equal to -3 times whatever y is. Remember, it's asking for $1. We're not going to give it $1. We're going to give it these 4 quarters right here. So this is going to be a -4 minus 11. So this is going to be x equals 12 minus 11. So this is x equals 1. So there's the other part. So we write down the answer. The answer on this one is 1 comma -4. And we're going to circle that and we are done. Okay, now let's turn our attention to this one right here. This is the last one. It's got an asterisk on it. It's got an asterisk for a reason. This one's a little stickier to work with. So it says, which variables should we isolate? Okay, well, the first thing we should do is we should kind of go through here and check for multiples. And what I mean by multiples is, are they all multiples of the same number? So are there 5s and 10s and 15s, or are there 3, 6, and 9 and 12 and so forth? Okay, so check for multiples. Usually we want to do the one with the smallest coefficient, okay, and check for negative coefficients, because we want to avoid kind of ones with negative coefficients. So let's run through here, and again, these are just general rules. So I would say, looking at this one, we don't want to get the x right here by itself, the one with the 5 in front, because when I get rid of the 5, I have to divide everything by 5. They're not multiples, so that's going to make things pretty ugly. Same thing with the 8. So let's turn our attention here. If we solve for the y, we're going to have to divide everything by 4, which is not going to go in well. But right here, take a look at that. That 2 right there would go into 4, and it would go into 18. Now we get another advantage here because I'm actually going to add 4y to both sides. So this is going to be 2x equals 4y minus 18. We had an equation with 2 negatives in it. Now we have an equation with only 1 negative in it. And now we'll go through and we'll divide everything by 2. So here's what we get. We get x is equal to, this is going to be a 2y minus 9. Now we're going to keep track of that. We're going to use that in a couple of different ways. The first thing we're going to do is we're going to say, look, that was the first equation. So I'm going to take this and I'm going to plug it into the other one. Okay, so I'm going to plug it in right here. So I'm going to write down 5, and we're going to write down what x equals, 2y minus 9, and then we're going to have plus 8y, and then equals negative 36. So let me just double check. 5 times whatever x was equal to. Looks good. There's the plus 8y, and then there's the equal negative 36. So let's check and see what we get here. This is 10y minus 45 plus 8y, and then over on this side we get a negative 36. Let's double check and make sure we've got this right here. Okay, so put these together. We get 18y minus 45 equals negative 36. We're going to add 45 here. So we get 18y equals, that's going to be a 9. And then we're going to divide by 18. So we get y equals, ooh, that doesn't go in evenly. We end up with a fraction here, which can be a little bit of a mess, but I think we get lucky on this one. So again, I'm going to change colors again. I'm going to put the 1/2 right there. So watch what happens with this. 2 times whatever y is. Well, y is 1/2. Watch this. So 2 times 1/2. Those are multiplicative inverses. Those cancel each other out, so those cancel to be a 1. So this is 1 minus 9. So that means x is equal to negative 8. So there's the other part. So even though this worked out to be a fraction, we've got a fairly easy solving process, especially where that was a multiple of 2, so it canceled off the 2 in the denominator. So here's the answer on this problem. The x is negative 8, so negative 8 comma 1/2. Totally okay to get fractions here. Remember, we wouldn't be able to get a fraction answer like this just by graphing unless we used a calculator. So really accurate method here. All right, I'd like to come back and take a look at one more aspect of this. You'll notice that on each one of these, we ended up solving and finding y first. We found the y value on each one of these first, but some people get the mistaken idea that we need to solve for a particular variable. You'll notice that we got y first on this one, and then we figured out what x was, and then we wrote the answer down here. I want to take a look at example 2a right here. I'm going to go ahead and erase this, and I'm going to bring back, let's see, where are we here? Put that like this. And then I want to solve this a slightly different way. What I'm going to do here is, instead of solving for this x right here, I'm going to solve for that y. And I'm going to show you a nice little trick. Sometimes this comes in handy. Again, it doesn't matter which variable we get by itself. We could have gotten this x by itself, that y by itself, this x by itself, that y by itself. It wouldn't make any difference. We just want to pick the easiest one. We found that x to be the easiest one to isolate. But let's go ahead and isolate this one. So let me show you a nice little trick. If we move this y to the other side by adding y, and move this x to the other side by subtracting x, we can basically take the two of these and we can flip them around. So what we end up with here is we end up with 2x, moving that to the other side, that would be a minus 6, move that to the other side, that would be a y. Now I've got the y isolated, and I'm going to take this and I'm going to put it right there. Okay, so I'm just going to solve this again and show you that we are going to get the same answer. The answer when we solved it before was 1 comma negative 4. We're going to get that same answer here. So I'm going to take this and I'm going to write down x plus 3 times y. Let's write down what y equals. 2x minus 6 equals negative 11. So we'll just double check this. I've got the x right here. I've got the plus 3. This is what we're putting in place of the y, and then it equals negative 11. So we're solving that equation. We've just replaced the y with what it equals. So we end up with x plus, this would be 6x, minus 18 equals negative 11. And then we'll put the two of these together. So this is going to be, let's see, 7x. And then I'll add the 18 to this side right here. So we end up with 7. So we'll divide both sides by 7, and we get x is equal to 1. So we've got that one right there. And then we'll just take this, and I'm going to change colors again. So I'm going to take this and plug this into right here. So when we plug this in, let's see what we have here. This is going to be 2 times 1 minus 6 equals y. So this is going to be 2 minus 6 equals y. So that means y equals negative 4. So here we go right here. We've got those two. And I'm going to change back to blue here. This means the answer on this one would be 1 comma negative 4, which is the same answer that we got down here, 1 comma negative 4. So it doesn't matter which one you solve for. We can solve for the first x, the second x, the first y, the second y. Doesn't make any difference, whichever one's the easiest. And kind of following these general guidelines right here, check for multiples, smallest coefficient, negative coefficients. Sometimes we can use those, whether it's positive or negative, to our advantage. So kind of keep those general ideas in mind, and good luck with the assignment.